Okay, everybody, time to recap the lesson. Just coming out of laryngitis, so the voice is a little raspy, but we can do it. Okay, so today we talked about maximum, minimum problems. What we did in class is we built a box. We found the biggest box, okay? That was a hands-on project, but we'll see that one on the other side. We'll do the box one, but on the front part of this, we have some problems. The first problem is this. We're going to build a fence for animals, okay? We have a barn that we'll use for one side of the rectangular fence. So we have 60 meters that we need to use for the rest of the fencing. So we want to make a rectangle. So we've got the width and the width, which we don't know how big the width is, so we're just going to call it W, because we can make this any size. We can make it really wide, we can make it really skinny, lots of different shapes. But what's the best shape that makes the biggest area? Well, if we call this W and W, then out of 60 meters, put some fencing here, some here, and what's left over goes onto the length. So that'd be 60 minus 2W, because you took some here and some here. Area, length times width, so it's 60 minus 2W times W. If I simplify this, I got the area with respect to width is a 60W minus a 2W squared. If I want to maximize it, I'm looking for really kind of like the vertex. We learned that one equation for the vertex is negative B over 2A. Well, that's B and that's A because it switched around. So I did my negative 60, negative B over 2A, negative 60 over 2 times negative 2, and I got 15. So I know the width has to be 15 feet. Okay, so I built it. I know the width has to be 15, 15, and that makes the length 30. So the best rectangle to make would be 15 by 30. That'd give you a total area of 450 meters squared. Any other dimension would make a smaller rectangle. The domain is from 0 to 30, not equal because you wouldn't have a rectangle, not equal because you wouldn't have a rectangle, okay? And the range is 0 to 450, okay? That's the total area. Okay, then on the back, we looked at what we did in class. We took a piece of paper, rectangular piece of paper, it was 28 by 31 centimeters. We cut out square corners, we folded it up. So we took this, folded it up, so we made a box. Here's our three-dimensional box. We know that this was 28, this was 21, but if we took 2 x's away from it, that makes the width 21 minus 2x. This was 28, but we took 2 x's away from it, makes it a 28 minus 2x because we took away the 2 x's. Volume's length times width times height. So my volume is x times 21 minus x times 28 minus 2x, okay? X is the size of the cut. So then we put it on the calculator, and we took a look at it, okay? And we saw, let's see if I can get my calculator back. Okay, I'll graph it. If I put in my x times my 21 minus 2x times my 28 minus 2x, window, and I knew that was about 1,000. Graph it. Oh, well, hold on. Really? Oh, I put the max in the wrong place. My bad. 15. There we go. Now let's look at it. Okay. Okay, there we found the maximum is right there. If I go to find out what the maximum is, calculate the maximum. I get the maximum to be about there at about 3.96. So my best cut is 3.96 to get the length. Put the 3.96 in for the length, got 3.8. If I need the width, I put 3.96 into the width, I got 13.84. Now what's the volume? The volume's the y value. Now my calculator gives me a 1,040, okay? Centimeters squared, cubed. The domain has to do with the cut. The smallest cut is from 0 to 10.5. You can't go more than 10.5 because if you go 10.5, you have no rectangle. and the volume is from 0 to 1,400, 1,040.08. Okay, and that's all I have. We had a homework assignment that goes along with it. If you have any questions, come see me. My voice is going.